My part 1 is number 5. Limit of x approaches negative 2, x worth in 2. I, I just evaluate the limit and simplify the expression, and I got the answer 4 in 2. My part 2 is 11, and I use the solution of I rewrite the expression into the form of a square root minus b squared of limit of y approaches negative 3, open parenthesis, square root of y squared minus 3 squared, close parenthesis. And I just factor the expression using a squared minus b squared equals open parenthesis a plus b close parenthesis, and open parenthesis a minus b close parenthesis. And I rewrite the terms using limit of y approaches negative 3, open parenthesis, square root of 2y squared plus y plus 6y plus 3. Include regroup terms into two proportional parts. And I factor the greatest common factor out. The limit of y approaches negative 3, open parenthesis, square root of y, open parenthesis, 2y plus 1, close parenthesis, plus 3, open parenthesis, 2y plus 1, close parenthesis. And I crossed out the common factor out and substituted. Like, limit of y approaches negative 3, open parenthesis, I cancel y plus 3, and I got I left y negative 3 and 2y plus 1. And I substitute negative 3 minus 3, 2x, open parenthesis, negative 3, close parenthesis, plus 1. And I substitute it all and substitute the expression. And I got the answer, square root of 6, 5. My part 3 is number 15. My problem and my solution are behind me. First, any expression multiplied by 1 remains the same. Since two opposites add up to 0, remove them from the expression. So, f1 exists, and I do the same as the first one, and I got the same answer, negative 3. So, limit of f of x exists, and for the last is the same too. So the three conditions are satisfied. Therefore, f of x equals x squared minus 3x minus 1 is continuous at c equals 1. My part 4 is 22. My problem is f of x equals 2x squared plus 4x. open parenthesis, negative 2, and 0, close parenthesis. I use the m equals limit of x approaches c, f of x minus f of c, x approaches c, and equals limit of h approaches 0. Since the given point is negative 2 and 0, I substitute negative 2 for a. So, my a is negative 2. Like limit of h approaches 0, open parenthesis, 2, open parenthesis, negative 2 plus h squared plus 4, open parenthesis, negative 2 plus h close parenthesis, minus, open parenthesis, 2x, open parenthesis, negative 2, close parenthesis squared, plus 4x, open parenthesis, negative 2, close parenthesis. So, I got the answer, negative 4. So, the point slope form is y minus 0 equals negative 4, open parenthesis, x minus, open parenthesis, negative 2, close parenthesis. So, I evaluate the limit and the slope m, the tangent line at negative 2 and 0 is m equals negative 4. And I rewrite the equation in slope or intercept form. So, I got the answer, y equals negative 4, x minus a. My part 4 is 25. G of x equals x cubed minus 4x, open parenthesis, 0 and 0, close parenthesis. So, since the given point is 0 and 0, I substitute 0 for a. So, limit of h approaches 0, open parenthesis, 0 plus h cubed minus 4, open parenthesis, 0 plus h, close parenthesis, minus, open parenthesis, 0 cubed minus 4x, 0, close parenthesis, and h. So, I got the answer, negative 4. So, my point slope form is y minus 0 equals 4, open parenthesis, x minus 0, close parenthesis. I rewrite the tangent line in point slope from using 0 and 0, and m4 equals negative 4. So, I rewrite the equation in slope-intercept form. So, I just remove the 0 and I got the answer, y equals negative 4x. My part 5 is 34. My problem is y equals 3x plus 4x squared plus 5 sine x. I take the derivatives of both sides. Y prime of x equals derivatives, open parenthesis, 3x plus 4x squared plus 5 sine x. And I use the differentiation rule. I calculate 4 times 2, and I got the answer. y prime of x equals 3x plus 8x plus 5 cosine x.